So proportional thinking is the idea that when things get bigger or smaller, they do so, like they grow everywhere in the same way. So for example, if I were to make juice from frozen concentrate and the can says I need 3 cups of water for every can of concentrate, if I want to make 4 cans of concentrate into juice, is my thinking, well, I'm using 3 extra cans of concentrate, so I need 3 extra cans of water? Or do I need 3 cans of concentrate for each can of concentrate? Sorry, 3 cans of water for each can of concentrate. So if I'm using 4 cans of concentrate, I need 4 times 3 is 12 cans of water. So hopefully you see that it's option 2, because otherwise your juice is going to be really, really, really strong and kind of yucky. Okay, so that's proportional thinking. And proportional thinking is kind of the thing that when you get it, and it seems really obvious. But it's something that something like 60% of adults struggle with, which just floored me when I saw that statistic. Okay, I'm just going to scale this page down a little bit. Um, um, when we're working with drawings, proportions are really important. So if I proportionally, the small lamp here is my original lamp. So if I'm looking at this drawing here on the right, when I enlarge it proportionally and I double it, the base is twice as big in the one on the left, and it's twice as tall. So it's grown by the same amount percentage-wise. In both dimensions, both directions, and they look the same. Like this one looks smaller, one looks bigger, but they look like the same lamp. In contrast, if I go down to the bottom, this one down here, and what I did is I made it 3 centimeters taller and 3 centimeters wider. It's skewed. It doesn't look right. Like they don't look like the same lamp anymore. They're not proportional. Okay. So we're going to be doing a lot of work on proportions now. So what I'm going to do now is I want you just to just play with these problems. And since the 3 of you are here, I'm actually going to get you to do that. For students watching the video, I will ask you to pause it and take as much time, a good 5 or 10 minutes to play around with these questions, see what you can figure out. Some of them are easy, some of them are much more challenging. And then come on back and we'll continue with the lesson when you're ready to. Okay, I will give you the answers to those questions, but I'm going to put it at the end of the video, not right here in the middle of the video. That was really just a get warmed up and try things. And I will tell you that questions 4, 5, and 6 are definitely challenging questions. Okay, so let's go on to page 4 then and formalize how we did this. If we were doing this in class, I would actually have students share with me how they solved those questions. We would go through it together as a class and do it on the board and see what strategies people came up with. I'm going to show you what is probably the easiest strategy for solving proportions of any type. So, and that is you set up a proportion. So a proportion is 2 equal fractions, okay? And the key to doing any sort of proportion is putting words down, okay? So I'm doing question 1 as my first example, and question 1 says, if a football player weighs 115 kilograms, what is the total weight of 11 players? And so some of you probably just went 115 times 11 and there's your answer, and that works great, absolutely. But if we're going to do it using proportions specifically, we would set up a proportion which would look like the things we're measuring. We have kilograms, and we have numbers. We have number of people that we're talking about. And then we do a proportion where something equals something. And when I teach this, I talk about the first one is the recipe. I don't know where I'm going to write that here. Let's do this here. So the first fraction is your recipe. And the second fraction is the reality. Okay, so what I mean by that is my recipe is that one player weighs 115 kilograms. Okay, and I knew where to put the 1 and the 115 because I had written it out in words off to the side. And it doesn't matter which one is top and bottom as long as you're consistent. Okay, and that's going to be a recurring theme through this whole unit. And then the second, the reality, is the other information that we're given is 11 people. So we're going to put that down as our number of people, and our unknown, or our X, is what's the mass of those players, okay? And then we can solve this using algebra, or we can solve it using cross multiply and divide. So what I'm going to do is I'm going to do over in this box here, I'm going to show you if I'm going to do this as if it were an algebra question. So I have 115 over 1 equals x over 10. And I ask myself, what's bothering the variable? Well, it's that 10. So I'm going to multiply this side by 10. And I'm going to multiply this side by 10. And what I end up with is x equals 10 times 115 divided by 1. And x equals, oh, sorry, I've got a different calculation in there. Oh, I can do this without a calculator, can't I? Yes. 1150 kilograms is my answer if I do it using algebra. If I use it doing cross multiply and divide, I'm going to go back over to the left here, and there's a phrase of multiply the pair, divide the spare. So I multiply the pair of numbers that I have diagonally across the equal sign, and then I divide it by my leftover number, which is the 1. So I get x equals 11 times, 115 divided by 1. Sorry, this should have been an 11 over here, but not important. And then my answer is going to be, I don't have my calculator. (11 times 115 is 1265 kilograms. And I'm going to fix that over here because otherwise people are going to look at my notes and wonder what the heck I was doing. (11, 1265). Okay. Oh. So of course, if you have questions, you can ask me. Okay, and then question 2, let's do an example for question 2, which was if 5 chocolate bars cost 75 cents, how much do 13 cost? So this is a question, in the example 1, we started off with 1 costs something, or 1 person weighs this much. So we're much less likely to use proportions if we're starting off with, we call that a unit quantity or unit rate. We know what one thing costs or one thing is worth. We don't know that in question 2, and proportions are even more useful with questions like that. But the process is the same. I'm going to put down my units. What am I talking about? I'm talking about money, and I'm talking about minutes. And my recipe is that the motorbike goes 10 minutes on 30 cents worth of fuel, and I want to know how long it'll run on $1.05 or 105 cents, $1.05. I'm doing it as dollars, and I'm wanting to know how many minutes that's going to be. So I'm going to get x equals, I'm going to multiply the pair, so it's going to be 10 times 1.05 divided by 0.3, and that is going to get me 35 minutes. Okay? Any questions on that? Okay, so there's an assignment. I would give you time to do it, but I'm not, because I want to just do the next page of notes, and then we're actually done the notes. And it's actually, so the first set of questions is just doing the cross multiply and divide. Okay, that's all it is. And then we'll go to section 1.4.3 or 4.1.3. And the one trick that makes proportion word problems easier to solve, like by 100 times easier to solve, is to use words, which I already told you. So use words. So, for example, a boat can travel 80 kilometers on 20 liters of gasoline. How far can it travel on 106 liters? So our words could be kilometers and liters, or it could be distance over the amount of gas. It actually doesn't matter, but what matters is that all of your numbers for distance, which is measured in kilometers, are going to be on the top or all on the bottom. You'll get the same answer if you do it that way. I'll do an example off to the side for that. They're going to be on the same row anyway, and the amount of gas you're using is going to be on the same row as well. So I've got my something equals something. My recipe is that I can go 80 kilometers on 20 liters. And I want to know how far I can go for 106 liters. So my x goes up here. So x equals 80 times 106 divided by 20. I get my calculator out and I get 424. And I know that my answer is in kilometers because my answer is up on top here and my units over here are kilometers. So I've recorded that already. And then just to show you it slightly different, if I put my liters over kilometers, my proportion is going to be 20 liters for 80 kilometers of distance. I've got 106 liters. How far can I go? X is going to be 80 times 106. Sorry, I shouldn't use an X there. Divided by 20. I'm going to get the same number of 424. The other thing I should just mention is that it doesn't matter if I do 80 times 106 or I do 106 times 80 and then divide by my 20. It doesn't matter because when you multiply things, it doesn't matter what order you multiply them in, you're going to get the same order, same answer. Okay? Any questions about that? All right, and this is a definitely be smart about your lazy situation. It's so much easier to just write down these two little symbols or words or something than to try and juggle in your brain and remember that that 80 you wrote down as a distance. Because if you did 80 over 20 times 106 over x, let me just write that down. If you wrote it as 80 over 20 equals 106 over x, you are going to get the wrong answer. So don't do that. And if you don't do this writing, you have to remember then where what information goes, and why make things harder on yourself. Okay, so the next thing I will do is do the answers. I'll work through those questions at the beginning of the section. All right. Okay, let's work through these questions on page 3. Question 1 we already went over. Question 2, one way that you might do it, not using a proportion specifically, would be to say, well, if I know that 0.75 is for 5 chocolates, I'm going to divide that by 5, and I find out that they're 15 cents each. And then I'm going to go 0.15 times 13 is $1.95, so it's $1.95 for the 13 chocolates. Question 3 we did. Question 4, I'm going to go number of chapters over how many minutes. So we know that she does 1 chapter in 30 minutes, and there are 14 chapters, so how many minutes is that going to be? Cross multiply and divide. M equals 30 times 14 divided by 1. M equals 420 minutes. And then you could say that divide that by 60 and you get 7 hours. For that question, this is kind of funny. When I'm in the proportion mode, I just do everything with proportions, even if there's a 1. If I saw this question sort of in a vacuum or in a different context than this, I would probably go 14 times 30. But the proportions just work so well when you get in the proportion zone. It makes everything just really easy. Question 5. So I've got, okay, so this one, I'm going to sort of throw something out here. There's a thing that comes up later in other contexts where anytime you have money and an amount, we always go cost over quantity. And that's because when we buy nuts, for example, we buy, it's $14 a pound, or it's, an apple is like $1.50. Apples are $1.50 a pound or something like that. So it's just this. It doesn't matter. You will get the same answer. But when you're trying to compare prices of things, you always want the cost over the quantity. So just do it now. Why not? Okay. So the cost here is $4.72 for 1.3 kilograms. And we want to know how much is the cost. That's supposed to be a C. What is the cost for 5.1 kilograms? So C equals 5.1 times 4.72 divided by 1.3. 1.3. So the cost is 18.5169 and some other numbers. And money we always write to the penny, unless context suggests that we should not, but usually you write it to the penny. Okay, question 6. Now this is where it gets interesting. There are a bunch of different ways to do this, but if I do it using proportions, this is how I would do it. So I've got 2 boys. I've got John and Mark, and I'm going to write that down because I'm going to be smart about my lazy and I don't want to have to remember who's on the top. Okay. And then I know that if John has 3, John has 3 times as many as Mark. So if Mark has 1 marble, then John has 3 marbles, right? And then I don't know how many Mark has, but it's going to be 1 times some number. I'm going to call it an M. And John has 3 times M. So for example, Mark could have 2 marbles and then John would have 6. If Mark has 3 marbles, then John has 9. Whatever the numbers are, John has got 3 times as many as Mark has. So now I've got, I could use proportions to solve. No, I can't because I don't have an actual, I haven't put my 32 in there. But what I do know is that the number of marbles that John has plus the number of marbles that Mark has is 32. So 4M is 32. And that means that M is 32 divided by 8, by 4 is 8. So then Mark has 8 marbles and John has 3 times 8, which is 24 marbles. And then I would always check that. I'm going to add my 8 plus my 24 to make sure that I get 32 because that's what I need to have. Okay, pause the video, try the next 2 questions now that you've had that. Okay, I'm going to solve these 2 in the same way. So I've got kid 1 and kid 2. And kid 1, lucky duck, gets 2 M&Ms for every 3 that the other kid gets. And this is going to be 2M and 3M, where M is some number. I don't know what it is yet. But I do know that 2M plus 3M is going to be 80, because that's how many M&Ms I have total. 5M equals 80. M equals 16. So kid 1 gets has 2M, which is 2 times 16, which is 32. And kid 2 has 3M, which is 3 times 16, which is 48. And if I add 32 and 48 together, I get 80. So I'm happy because I got the right number of M&Ms. And then with the MP3 player, I've got Sandra paying some money and Mom paying some money. And for every $2 that Sandra's paying, Mom is paying $5. So Sandra's going to pay 2 times some amount. I call it P, and Mom's going to call 5 times some amount. 2P plus 5P is the total amount of money, which is 210. 7P equals 210, P equals 30. So Sandra is going to pay 2P, which is 2 times 30, 30, which is 60. And Mom is going to pay 5P, which is 5 times 30, which is 150. If I add those together, I get 210. Yay! There are other ways to solve these questions for sure. But I think these are probably either I think these are the easiest, or I think they're the easiest today because I'm working in proportions. Take your pick. All right, go do the practice and the quiz will be posted for you soon. Have a great day. Bye.